The world we know is changing. A new technological era is upon us, the quantum revolution. This revolution is rooted in the strange and counterintuitive world of quantum mechanics. Quantum mechanics is the study of the very, very small. It explores the bizarre behavior of atoms and the particles within them. For centuries, our technology relied on classical physics, the physics of everyday objects. But classical physics fails to explain the oddities of the quantum world. Things like quantum superposition and entanglement. These concepts allow particles to be in multiple states at once or instantly influence each other across vast distances. These strange quantum phenomena are now being harnessed. We're on the verge of building technologies that were once considered science fiction. These technologies have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. The quantum revolution is not just a technological shift, it's a paradigm shift. It forces us to rethink our understanding of reality itself. The story of quantum mechanics is a story of brilliant minds that dared to venture into the unknown. These minds dared to challenge the established norms of physics, questioning the very fabric of reality as it was understood. At the beginning of the 20th century, scientists like Max Planck began noticing something odd, something that didn't fit within the classical theories. The energy of light seemed to come in discrete packets or quanta rather than a continuous wave. This observation led to a groundbreaking theory, Planck's law, which fundamentally changed our understanding of energy. Planck's law stated that energy is not continuous but quantized, meaning it comes in specific, indivisible amounts. This discovery opened the door to a whole new understanding of the universe, one that was far more complex and mysterious than previously imagined. Albert Einstein, a young patent clerk at the time, took Planck's idea further, expanding on it in ways that would revolutionize science. He proposed that light itself is made up of these energy packets, which we now call photons, a concept that was both radical and transformative. This concept revolutionized our understanding of light and electromagnetism, laying the groundwork for modern physics. Then came Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, each contributing their own groundbreaking ideas. They developed the framework of quantum mechanics, a new and revolutionary way to understand the microscopic world. Bohr's model of the atom with electrons orbiting the nucleus was a radical departure from classical physics, introducing a new way to visualize atomic structure. Heisenberg's uncertainty principle introduced the idea that certain pairs of properties, like position and momentum, cannot be known simultaneously with perfect accuracy, adding a layer of fundamental unpredictability to the universe. Schrödinger's wave equation provided a mathematical description of the behavior of quantum particles, offering a new way to predict their behavior. This equation remains a cornerstone of quantum mechanics, essential for understanding the quantum world. These pioneers of quantum mechanics laid the foundation for one of the most successful scientific theories in history, a theory that continues to shape our understanding of the universe today. The early decades of the 20th century saw the birth of quantum mechanics, a revolutionary field that fundamentally changed our understanding of the universe. This new understanding of the universe began to reshape technology in ways that were previously unimaginable. One of the most profound examples of this technological revolution is the invention of the transistor in 1947 by John Bardeen, Walter Brattain, and William Shockley. Transistors are tiny devices that control the flow of electricity, acting as switches or amplifiers in electronic circuits. They rely on the quantum mechanical behavior of electrons in semiconductors. The invention of the transistor revolutionized electronics, making it possible to create smaller, faster, and more efficient devices. It paved the way for the development of modern technology, including smartphones, laptops, and countless other electronic devices that we rely on today. From radios to computers, the impact of the transistor is immeasurable, transforming the way we communicate, work, and live. It is no exaggeration to say that the transistor is one of the most important inventions of the 20th century, earning its inventors the Nobel Prize in Physics in 1956. Another groundbreaking invention that emerged from the principles of quantum mechanics is the laser. In 1960, Theodore Maiman built the first working laser, a device that would go on to have a profound impact on numerous fields. Lasers utilize the quantum phenomenon of stimulated emission to produce highly focused beams of light, which can be precisely controlled and directed. Lasers have become indispensable tools in various fields, from manufacturing and medicine to scientific research and telecommunications. They are used in telecommunications to transmit data over long distances, in medicine for procedures like laser eye surgery, and in manufacturing for cutting and welding materials with precision. From barcode scanners in supermarkets to life-saving medical procedures, lasers have become an integral part of our daily lives. The invention of the transistor and the laser demonstrated the power of quantum mechanics, showcasing how fundamental scientific discoveries can lead to transformative technological advancements. These innovations marked the beginning of a new era in technology, one that continues to evolve and shape our world in ways we are only beginning to understand. Section 4. Entanglement, the spooky action at a distance. One of the most mind-boggling concepts in quantum mechanics is entanglement. Entanglement occurs when two or more particles become linked. This link is regardless of the distance separating them. When entangled, the state of one particle instantly influences the state of the other, even if they are light years apart. This spooky action at a distance, as Einstein famously called it, has puzzled scientists and philosophers for decades. How can two particles be so intimately connected even when separated by vast distances? The answer lies in the strange nature of quantum mechanics. In the quantum world, particles do not have definite properties until they are measured. When entangled particles are measured, their fates become intertwined. Measuring one particle instantly determines the state of the other. This connection transcends space and time, challenging our classical intuitions. Entanglement is not just a theoretical curiosity. It has profound implications for our understanding of the universe and the potential for future technologies. Section 5. Quantum computing, a new era of computation. Welcome to the fascinating world of quantum computing, where the boundaries of technology are being pushed beyond our wildest dreams. The laws of quantum mechanics have opened up possibilities beyond our imagination. These principles, which govern the behavior of particles at the smallest scales, are now being harnessed to revolutionize computing. One of the most exciting developments in this field is quantum computing. This groundbreaking technology promises to transform the way we process information. Traditional computers store information as bits, which can be either 0 or 1. This binary system has been the foundation of computing for decades. Quantum computers, on the other hand, use qubits. These quantum bits are capable of representing and processing information in ways that classical bits cannot. Qubits leverage quantum phenomena like superposition and entanglement. Superposition allows qubits to exist in multiple states at once, while entanglement links qubits in ways that defy classical logic. This allows them to exist in a combination of 0 and 1 simultaneously. This duality is what gives quantum computers their extraordinary power. This unique feature of qubits gives quantum computers a significant advantage. They can solve complex problems much faster than traditional computers. They can perform computations that are impossible for even the most powerful classical computers. This opens up new realms of possibility in data processing and problem solving. Imagine a massive library with billions of books. Each book represents a piece of data or a potential solution to a problem. A classical computer would have to search through each book one by one to find specific information. This process can be incredibly time-consuming. A quantum computer could analyze all the books simultaneously. This parallel processing capability is one of the key advantages of quantum computing. This would drastically reduce the time needed to find the desired information. Tasks that once took days or even years could be completed in a matter of seconds. Quantum computers have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. The impact of this technology could be profound and far-reaching. They could enable us to develop new drugs, design innovative materials, and create more powerful artificial intelligence algorithms. The future of quantum computing is bright, and its possibilities are endless.